everyone. In this video, I'll be presenting the computer vision assignments. So in this, this assignment has been segregated into four different parts. The first one comes as a supervised constructive learning, where we'll be using the new losses for this. This is the example, and this is the transfer learning on the various models, and this is the zero shot transfer learning for Colab, and part 4 is the X-ray phenomenon classification with the convert and the 3D model classification for CT scans and all. So I have demonstrated these into the 5 different collabs. So here is the video of them, and this is the updated version of the Git. So this video also will be present in this link, and attach it to the 4 collabs are here in this direct link. So here I gave the a direct Google link, Google Drive link, so that it will directly load from whenever we click any particular collab files. So this is the structure of the files, and these are the nodes and the tools versions and all which I used to cover this task. So to begin with, we start with the supervised constructive learning. First one will load all the pre-built models, and GPU we set as a TensorFlow version of 2.1.8, and after that we'll load the dataset, and we load the CIFAR train dataset, and we normalize the images and create a train and test for this, and after that we add the labels, and plotting the random images for the training set is done here, and plotting the class distribution of the training set, and here is the function to create the TF data pipelines, and this is creating a data set as a dummy data set which created train branches, and the validation branches and the test branches are here, and after that here is the modular architecture plus the custom SupCon class. So this is the one of the architecture where we build a CNN feature extraction and the Softmax header classification for this, and this is the Softmax user, the encoder models, and installing the models is done here, and after that the custom supervised constructor loss, that is a mutual implementation. This customer loss mimics the TensorFlow add-ons and losses NPPA's loss as well, but in the full native workflow for TensorFlow 2.1. And next we comes to the trained Softmax based model. So here is a complete Softmax based model for this, and this is the Softmax train curves accuracy and the loss wise, and here we define the data augmentation pipelines for the dual views. The first one for the random chopping, and the second one is for the horizontal flipping. The Keras based I tried both and it did not work, but I went to the alternative model, that is a Keras based augmented model, and written the 2 augmented views of the above 2, and building the SupCon dataset pipelines, and I used a light encoder to reduce the training time and the memory usage. So it was running on the CPU, so I reduced these things, and just the small subset of the C510 is the X-ray and small, and the Y-train data, and the constructive loss of the training, and the optimizer for the SupCon loss, and this is the training classifier fire, and these are the results, and the SupCon accuracy and the loss, and this is the visualizations for the embedding t-SNEs, and this is the t-SNE SupCon embeddings, and this is the validation accuracy comparison for both of them. And this is done, then we move on to the next part, that is a transfer learning on various modulations. So in this image transfer learning is done loading the data, and here is the loading the image sizes, and loading the cat versus dog simulations. So this is the basically part 2 of the assignment, transfer learning of the various models. So here is the loading the model, and here is the training the model with the 3 approaches, and here is the image transfer learning where where here is the fine tuning setup for the model, and like I have performed the fine tuning for this, and this is the like after fine tuning the accuracy and the loss and the validation score for this. And the same way as I perform the audio transfer learning for the chunk one, so here the uploading the data and the loading the YAMNet model for the TF hub and extracting the features from it, and simulating the binary tables from the 0 to 1 and the training the lightweight classifiers for this. And also video transfer learning using like i3D TensorFlow hub, and loading i3D models from the TF hub that is pre-trained on the Kintex 400. And this is simulated like embeddings, and these are the splits into the train and test sets, and their accuracy and their recall F1 score and the support of the scores and the test classifier. And the last one comes is NLP classifiers. So in the NLP classifiers, first we load the data and the text and the labels for this, and the embeddings has been performed here, and the other training and testing, and like at last the accuracy is one, like it like as we performed in the dummy set, so it was very small. And next we move on to the zeros short image classifier like using the CLP. So this is the model for that, and loading the pre-trained CLIP model and the tokenizer, and it is example for that, like working reliable image of the dog. And like here is like download the image for the headers, like handling the image loading, and this is the input image. Like after that, like we perform the run clip prediction for the best matching labels. Like we perform that like prediction labels and the confirmation of that. And like after the transfer learning using the TensorFlow hub, so it was done. And is the loading models and the TF flow dataset, and the all the other things are performed on that. And here is loading the efficient light via hub load, and like after that compiling the models with optimizer loss and the mixture precision for this. And like after that, like it ran on the 5 approaches, and these are the accuracies for that, like the accuracy loss and the validation and other things. And next we on to the vision classifiers. So for vision classifiers, like firstly, like explain in the brief, like first chunk like is a setup of a pre-processing of a minis data set. So it ran on the minis data set, train and the test splits are in this manner. And like after that, like I have performed loaded the models and the tested for it and evaluated in the same cell. So here is the like training for 3 approaches and evaluating the efficient model, like accuracy and the loss. So it ran for very less amount of like approaches, that's why accuracy is low. If it ran for very long time, and the model if we use for very large model, then the accuracy will be increased. And after that, the next chunk is the bit transfer learning using the ResNet 502 v2 as a substitute to the BIoT model, or like heavier model not compatible with the collab friendly. So I use lighter weight models for this. Here also the building the model, combining training and evaluation, so based upon the same example as above. So it I have performed for this. And also I did the same way for like mini MLP pixel for scratch the version user. And like here, like pitch input images, like NLP patch mixer and NLP cache mixer has been performed in this. So here is a friendly way of the displaying the all. So here is the evaluation matrices for that, and here is accuracy and the loss. So this performed a little bit better compared to other models. So here is the last one, like convenet, like inspired from the custom convenet. And like it's a lighter weight model again. So in this model, like I have performed the same step as above, and it is example for that, like convolution of the accuracy and the loss for this. And at last, the other part of the assignment is to like check with the extra phenomenon classification with a convenient or a 3D image with a CT scan. For this, like I have performed install the Kaggle, and like I loaded my JSON file, and from that I have downloaded the test x-ray data set, and from that I have loaded and extracted the features, and like training loading the data set and perform the preference of functions and training test validations and all the other things. And here is the lightweight convolute, like where in this like I have mentioned like how many dense layer and the dropouts, and like convolutional layer, like how many max convolutional layers like will be set on this. And at the lat it will be dense of 64 layers as activation of ReLU, and a dense of 1 and as activation of sigmoid function. So and like combining the training models and evaluating the score for this. And this is the output as I expected, like zero 0.9, and the accuracy is 0.7. And next is the plotting the training history. So this is the model history and the model loss in the training and validation. And here is the uh, reload set without the much. So here is the confusion matrix for the F1 recall and the other scores. And chunked this is the next task where we simulate the CD like 3D CT scan volumes for demo. So this is the shape for that. And like here is the model trained, and like here is the accuracy for that and the loss, and here is the plots for that CT scan classifier. So this completes the entire assignment. So I'll be posting this video in the YouTube, and like that link will be in this GitHub. Thank you so much.